start. But that's how Nerdist podcast does their stuff. Like they like have like big end celebrities there. All they do is like, yeah, as soon as they like walk into the door, they just hit record and they just flow in from having a normal conversation into talking to like Tom Hanks or something, and it's just a really chill conversation. Anyways, hi folks. Welcome to FTP. This is like week 4. I am getting into the Jeff mentality now. What, week 3?
Yeah.
Oh,
Yeah,
sorry.
We have the first week.
Week 3 of FTP, week 4 of the semester.
Yeah.
Right. Well, now that we've made that distinction. Okay, so we're going to get into loops today. Loops are super, super good for when you need to do, as you would imagine, a lot of one thing, but don't want to type 30 lines of code to do it. So there, you'll see these 3 or 4-ish loops very commonly across a bunch of different languages. Most commonly being the for loop. And so when you look at the for loop, it looks like an absolute mess because you see all this business and what are each of these, what are they doing. So let's break them down really quickly. So as we said, for loop is going to iterate over like some set of instructions a certain amount of times. And there are 3 pieces to actually getting a for loop started, as you can see here. So we've got this, yes? Yep.
It's kind of hard to see the
Yep, we got it.
Oh, okay.
Sorry. It'll make it.
I'm really excited and Jess, I'm coughing.
Yeah, like, hey, there we go. There's the good one. Cool, good. Thank you for pointing that out. Okay, cool. So to get a for loop started, we're going to need something that's called an iterator, and it sounds a little bit weird. All it is, it's a way for us to like count how many times we have gone through this for loop. So right off the bat, when you do a for loop, more often than not, you're going to do an int I is equal to 0. So we're starting our starting count is going to be 0 for this for loop. The only I is just a convention. You could name it anything you want, but I is the easiest. If you've got one for loop inside of another, you might want to do like J or something like that. So just because if you have a for loop inside of another for loop, yes.
Okay. So at some point I'll have a rant about naming conventions for people who have been here before. I've already had that rant. Why is it okay for us to name? Normally you name variables and something that makes sense to you, so that when you go back you'll know what that variable means. I doesn't really mean anything, so you don't have to name it anything in particular, because it's just telling you, like, the fact that it's in the for loop is telling you that it's iterating for the for loop, which actually is probably why it's I instead of like another letter, like A is I iteration, whatever. I only mention this because I've done that. I've explained this a few times this week, so. But it doesn't really mean anything. It's just telling you how many times you're looping through.
Yeah, so as we have here, as we showed, you can completely replace it with something else. It'd be totally fine. Unfortunately, we're not going to be too fun today, and we're going to keep it to that. Yeah, I know, sorry. Okay, so yeah, first part, you're just setting up something called your iterator. It's going to keep a count for the for loop. This next part is going to be the condition that is evaluated every time you go through the for loop. So by doing every time it goes through the for loop, it's going to pop back up here, come to this, and go, okay, well, is our iterator still less than 10? If it is, then we're going to go ahead and do I++ and pop right back into the for loop. And I can actually show this really quick by just throw a breakpoint right there. First let's see what this runs without doing a breakpoint. Okay, so let me get the. Here we go. Bam, cool. All right, so as you see, yeah, it loops, it counts just 1 through 10. Pretty simple. So let's actually take a look at what it's doing. Okay, so right off the bat again, we're establishing that. Yeah. Anyways. Sorry, the video stopped because F10 is how you also stop Camtasia, but it's also how you step through something. So I think, where is it? Not redo. Oh, where's the actual step into? Step over. Okay, great, cool. All right. So as I was saying, okay, we have int I is equal to 0, so we established that. We'll do a step over. So next, it's going to right off the bat evaluate, is I less than 10? It says. Yes, it still is. So we're popping right here, right back into our for loop. So when it's done with the loop, goes back up, it does an I++, and then it goes right back in, okay, checks I less than 10, yes, and so on and so forth. You get the idea. Just so to reiterate, 3 parts of this: iterator, condition that we're going to keep on doing our loop, and what's going to happen when we finish one chunk of our for loop, if that makes sense. Cool?
Would it make more sense? Well, I mean, that's a declaration of an iterator, and the I++ is actually performing the iteration.
Yeah. Oh, yeah. Right. Okay. That's actually a good way to that too. Yeah. So declaring the iterator and then performing the iteration. That's that's a pretty good way of thinking about that too. Okay. So let's stop the debugger. Cool. So then we have our next one. Let me go ahead and comment this one out. So that's our for loop. Then we have, just go take that out. We've got another one that's called a while loop that is a little bit simpler, but gives you, it's always about, whenever you're doing programming, it's always about trade-offs. Something might be simpler, but you're not going to be able to get like super nitty-gritty with it. Like, for the for loop, we have all these things that we can establish up here to make our for loop as specific as we need it to be in terms of like iterating things. The while loop is definitely simpler and easier to use, but we've only got this one little conditional statement here.
Can I go into a Billism real quick?
Yes.
Okay, so if you ever take a class with Bill Buchmann, especially a programming one with Bill Buchmann, he talks about how computer science isn't really computer science, it's computer design. You're always making trade-offs and making design decisions when you're programming. And in this particular instance, the design decision that you're trading off is how much control you have over the amount, how your loop is looping, basically. Whiles are, I mean, it's not like particularly easy to make a while turn into an infinite loop, but
it's a good thing. I mean,
Right.
we'll do that in a second. Like
Yeah.
it's pretty fun to do. Just watch something kind of break and go into an infinite loop. Yeah. So the while is just going to. I mean, it functions a little bit. It's like kind of if you mix like a for loop with an if statement almost, kind of. So the while loop is going to go, okay, so it's going to look at this condition, and if that condition returns true, it'll go ahead and run into this code block. And it will keep doing that for as long as this condition is true. It will keep going and going and going. Hence why it's kind of, with the for loop, there's a definite, like, it'll pop out of here because we set it to be so. The while loop does have a chance that, you can create this infinite loop. And so let's just, this will print out the exact same thing that the for loop did. So just, yep. So it just goes 0 through 9. Or actually, you know what, I think did this do 0 through 9 or did it do 1 through 9? I can't remember. 1 through 10 it did?
Mm-hmm.
Oh, interesting. Okay, well that's a slight little difference there. And you can, again, if that's a little bit confusing as to why it's doing that, again, you can create this at home and then step through it and see, like, oh, like this does one more iteration before it like pops out or something like that. So yeah, so it prints out the same exact thing, but what if we, yeah?
I know why it's happening that way. I think I know why that's happening.
Do you want to say?
So in our for loop, we're not using counter as our iterator. Like counter's not iterating. It's I that's iterating. So counter starts at 0, and then we're immediately like incrementing it and looping again. That's why it's doing it that way.
Oh, right, and it's
Yeah.
because I got the counter after the, okay.
Yeah, that too. Yeah.
Okay, no, that's a good slight little difference though. Keep everyone on their toes. That's great.
Programming.
Yeah, really. Okay, so what we'll do instead, just to make an infinite loop, like bool. That's a pretty long one, yeah.
So I was actually gonna go into this after explaining both of the while loops, well, the while and the do while loop.
Mm-hmm.
But since you're doing this example, this is one of those like choices where you would use a while loop as opposed to a for loop. Yay! Wait until it crashes. It's gonna be good.
I wonder how long that'll take.
Actually, you're just console.writing, so it might not. It will eventually, but it might take a while.
Yeah, it's probably gonna take a hot minute. So like, you know, we just have all of these.
Yeah, right.
So
This is fun. But this is one of those situations where you would use a while instead of a for loop. I mean, in a for loop you're making the iterator, but whiles you're taking whatever parameters you're taking inside of it. Like the while is just determining whether or not that's true or false. So you can put a bool in there. Like by nature can put a bool in there, and usually do. But yeah, that's something to keep in mind. I mean, for loops are too, but it's a little bit.
No, so as a rule of thumb, whenever you're doing something in a while loop, you need to have some kind of condition that's going to, some set of rules that like to change this initial condition so it can actually step out of the while loop and continue to execute the rest of your program. Unless your program is to create an infinite loop, in which case, like, you know, have like go at it. But usually we're going to want to pop out of our while loop at some point, hence the counter thing I did earlier.
Yeah. While true.
Yep.
Do this.
Yep.
While true.
Yeah.
Or while not true. Do this.
Yep. Yeah, okay, so then the last one that we have is extremely similar. So similar, in fact, that I have, to this day, I think, used it outside of a homework context maybe twice. Yeah, so, and you can find particular situations for them. More often than not, you're just going to be doing a while loop, but let me explain. So a do-while loop, the only difference between this and a while loop is that, again, the way that a while loop works is that first it's going to look at this, and then if this is true, jump into this block, right? The do while is actually going to execute this block of code first, and then when it's done executing that, then check the while loop. That's literally it.
So it just does the code first, then checks it.
Yes,
Yes.
it's literally the only difference.
Yeah, it's while do and do while.
Yep.
That's,
Oh, yeah.
That's the difference.
No, that's a good way of thinking
While
about it.
do,
Yeah.
do while.
So they're just, it changes the order of execution.
So nuanced. It's rarely gonna come up. Like I've never found a situation yet where I couldn't use a while loop. They exist.
And, you know, and it's all going to depend on how you program, pretty much.
Design decisions.
Yeah.
Computer design.
Okay, cool. And so then the only other one that I don't have in here is something called a for each, which I can talk about a little bit more conceptually. I can. Oh, let me think about this. You know, I might be able to whip up a quick little example. But so for each, what for each is going to do is it's important for when you're using collections of things. If anyone has heard of arrays or lists in C# at all, for those of you who haven't, pretty much think of them as a big collection of one, like for our purposes, a big collection of one type of variable. So you could have a like an array with 100 like things in it, all of them being integers, all of them being like people's like birthday, or well, no, birthdays would be more like strings, like ages or something, or strings that are like a classroom's like name or something, or sorry, classroom's name. Students within a classes, and all of their names are in a big list or a big array. So what for each is going to do is it's going to perform like a specific set of actions that you set. You know, just like any of these, it's going to perform whatever's within the code block here for each one of those elements that you have within either the list or the array. So if I can, let me create a list really quick, and don't worry about the syntax here. Give me just a second. Let's do a list of type string. Come on. Be happy? Nice, cool. Okay, so I'm gonna just do give me names, give me names. Is that how you spell Cindy?
Yeah.
Okay, next one's gonna be Bowser, because that's how I feel.
Reginald.
That looks right. That looks great.
Yeah, you did.
Okay, cool. Now, is that gonna? No, it's not gonna fly. Wait a second. Oh, I thought usually you can do that. Oh, you know what? I didn't. Okay, hold on. No, I know what I did wrong. I should have done. This is not a good convention. Do not do this. I'll do this, and then I can do...
Oh, I see what you're doing.
Yeah.
I mean, you can also technically just declare them all inside of the list.
Oh, yeah, I could do that too as well, couldn't I?
Yeah. So there's a few ways that you can load a list. This is a way to do it.
Yeah, hold on, sorry.
This is actually a good way to do it if you don't know.
I was gonna
What
load.
they
I was
are
gonna load
right
them like
away.
individually.
Yeah. But if you know, in a situation where you know what information is going into a list, you just throw it in when you're declaring the list.
Yeah.
Just like, oh, this is a list of names, and here are the names.
Right. Yeah. So. Okay. All right. Cool. So by the way, that's a way that you can establish a bunch of different like variables of the same type and give them different names without actually giving them a value yet, just to save like line space. So yeah, doing these commas here will be like, oh, we're going to create a string of name 1, name 2, name 3. So now you have 4 strings here that you can load things into. You do that with ints, floats, whatever. Just it's something that I prefer. Just looks cleaner to me, most especially when all of those things are like floats or strings or ints that are like related to one another in some way. So yeah, okay. So we have these, and we have our name list up here. So let's do.
Oh yeah, I forgot it's .add.
Yeah, but it's not.
It's not push and pop.
Nope, not push pop.
Push and pop.
Yeah. So what I'm doing here is this is just a function that every single list in C# has. The add does exactly what you think it would. Just it throws whatever variable that you're putting in there into that said list. Why are you giving me? Oh, I spelled. Wait, no, I spelled that right. Okay, no.
Yeah, no.
IntelliSense is just being really slow.
Sometimes we will be indulgent. It's fine.
It's exceptionally helpful. Okay, so now all I did here is I took all of these, I threw them into this list that's called name list, and now what we're gonna do is start our for each. Let's see if you can remember how the formatting of this goes. For each.
It's like this.
Oh, nice.
Yeah. So that's like your generic like for each item in this
So
list.
it's
And it doesn't have to be a list. It can be an array. The other stuff. Any form of collections. For each will.
not sting but string. Hey.
For each
Okay,
thing.
cool. Yeah, for each.
Like the artist.
Yeah, exactly. No, the wrestler. Everything always comes back to
Oh, yeah,
wrestlers.
the wrestler. The professional wrestler.
Yep. I think he's still actually like doing stuff. I think so.
I have no idea. It's gotta be Hello right now. Well, actually no. Maybe not.
I don't know. Ooh, not name 1. S. Right. Okay.
Uh-huh.
All right. So again, establish our strings, threw them into this list called name list. And then, so this is the formatting of the for each. So it's going to be for each, whatever the type of the thing in the list is. And then again, this S here is the same thing as the I for the for loop iterator. It's just you can name this whatever you want. This again, string this could be names. Like that's completely fine. It's just a way for the loop to keep track of like, hey, what are we like throwing that string variable into so that we can reference it within that code block. So yeah, so now if we go ahead and I think this is fun. This should be okay. Oop, nope. Hey, not you.
I don't know why with for each
Goodbye.
I like to name them, like name my variables more. But this is like a personal preference thing, I think.
Yeah, absolutely
Yeah.
right.
Just so I remember what I'm doing.
Okay.
I think it's kind of helpful though when you have like
Oops.
exactly how Zach did it. He's got a bunch of names, and then all of a sudden these names are being with S.
Yeah,
Right.
and that's
For my brain to understand.
totally, and that's the convention that you'll see, unfortunately. But I'm glad that made a little bit more sense. Yeah.
So in all loops, they usually have a variable that they're defining in the like signature.
Mm-hmm.
Yep.
There's like int I or string S. Like loops, that's like a loop thing to make one that you're never gonna really use again except inside the loop.
Except for
Yes, except for whiles.
yeah.
Right.
Whiles take in other variables. That's also another design decision why we would use whiles instead. If you were worried about your variables, or if you already had another variable like provided to you. I use whiles a lot in physical stuff with Arduino, so it's like while
Another good example that I can think of specifically for game programming class, and I'll do this on the board a little bit since we'll get into operators in just a second. So, common thing in some games is if you want to be spawning some enemies in like different locations on the screen or something, one thing that's pretty important is that you don't want enemies to spawn on top of one another. You don't want them to overlap because that doesn't look good, and then your collision gets all like screwed up, and it's not a good time. So in pseudocode, like you have them popping up here and here and here, but at some point in that random like generation algorithm that you have set up, you want to throw a while loop in there that goes, hey, so while this thing isn't touching something else, well, I guess actually the way that would go is while this, whatever your enemy is, makes contact with like another enemy on screen after you've set its position, reset that position. And so it'll just keep going through like this random loop of, oh, like let's try and put it here. Nope, there's an enemy there. Oh, let's try and put it here. Nope, it's overlapping on something else. And finally, when it does like get into its own space, it'll break out of that while loop because it's not intersecting with anything else. Does that make sense a little bit, at least? Like, not so much in a programming sense because that would be a kind of a deep dive, but at least. I hope so. I hope so.
Well,
Right.
assuming you all are game people. Well, even if you're not a game person, sometimes you'll be dealing with colliders. Well, colliders,
Yeah.
quote unquote. The abstract concept.
Yeah.
The abstract concept.
Okay, so for eaches are just nice when you have a sizable collection of something and you need to do the same thing for each of those things within either that list or that array. We can get into difference in like collections later. Folks who are doing C++ right now might be more familiar with arrays or vectors even.
Oh yeah, vectors.
Yeah. Lists are, I don't know if, I'm sure C# is not the first one to do lists necessarily. I highly doubt it. But the way that you can think of it right now is C#'s list is the nice, padded, easy, flexible version of an array, kind of.
Yeah, so this actually isn't too hard of a concept to explain. But arrays they have a fixed amount of items in it. Like you tell an array it has this many things in it. The difference between that and a list is a list doesn't have those bounds on it. You can keep putting stuff in that list.
Yeah.
And it goes on and on forever. Once again, the design trade-off of that is that lists are they take up a lot more memory because the compiler doesn't know how many items are going to be in it. So it kind of makes that room, or buffers out that room for that. Whereas arrays, it knows exactly how much memory you need for this. So they're just faster usually.
Right.
Yeah.
That's why if anyone ever does like hardware stuff, you're probably just going to be working in arrays because they are super quick. Like they're much more efficient than lists, or not even sure about like vectors, but maybe.
Yeah, probably.
Yeah.
Vectors are pretty flexible too.
They are.
Vectors are flexible.
So yeah, we can do a little bit on collections another day for
Let's talk
sure.
about collections eventually.
Yeah.
Collections are a good thing to talk
So now we can kind of start talking about different operators, and you guys have run into a couple of these already. I don't really.
Yeah.
Oh, sorry.
Do
Did you?
want me to start running
Okay.
them?
Yeah. Do you want to go for it?
Yeah.
Okay.
I did this last time. Does anybody need any of these? I'm just erasing things. I figured.
So operators. Operators are exceptionally important in any programming language. Again, you're probably going to see a lot of these very commonly around. So yeah, we're just going to write out a couple of them. But even if we go into, is Chrome going to work? Hey, Chrome works on this one. Nice.
Is a semicolon an operator?
Is it the Terminator?
It's a Terminator.
Like
yeah,
like
but,
Arnold Schwarzenegger.
But is it? I mean, I feel like that's kind of a nuanced thing.
Let's find out.
Not as an operator. Yeah, it's just.
Did I spell that right? C#6.
Yeah.
Hey, yeah.
Yeah.
Semicolon
Okay,
technically is
good.
an
I was
operator.
right.
Yep.
I thought so. Because I'm like.
Hey, nice. So we'll zoom
Oh
in a
wait,
little.
that's not how you do that in programming.
There we go. Okay, doke. So, yeah, there are. Oh, wait, even your operators. Yeah, those are a little bit. All your operators. Okay. So when we're talking about operators, we're talking right.
Yeah.
We're talking about a pretty broad family of things. There are arithmetic operators that can add two integers together. There are comparison operators that the ones like these where it's a double equal, so it's checking to see if something's value is equivalent to another thing's value. There's the
Ooh, that's a good way to put that.
what?
I always so usually the way I explain the difference between equals and equals is equals is like this is this, and then equals is this equals this. But I like is equivalent better.
There you go.
There you go. I like that.
Yeah, again, some of these are, like I said before, comparison. So you're doing greater than, less than, or greater or equal to. Some of them are a little bit different. So actually, you know what? I can show this off better in here. So let's go ahead and comment out this business. We'll make a little bit of room for ourselves here. Has anyone seen the double ampersand sign or like the double pipes at all yet? Do like the and the fours at all? Okay, I'm seeing a mix of reactions here. So let's do something quick. Set that equal to true. So do a string. We'll do call string today. We'll set that equal to Friday. Oh, are you looking for more arithmetic
Yeah, I'm
operator?
trying to think of more.
There's the dot operator technically. You want to get nitty gritty?
Oh,
The
for
dot
X.
is technically an operator. Yeah,
Oh,
but
yeah,
that
it
kind
is.
of gets off the deep end though, sort of.
No, I think that's important.
Yeah.
To know
So
what that's
let's
doing.
do. Yeah, of course.
Yes.
Yeah, those are important too.
Yeah, that's a good one. Actually, I'm gonna ask you, Zach.
Yep.
Because sometimes I get tripped up with this.
Yes.
Difference between plus equals and plus plus.
Oh, so yeah, that's totally cool. So whenever you have plus plus after something, that means it's going to be iterating. So like we had before with the for loop, if you have in plus plus, it's just going to increment that by one. And in the same sort of sense, there's a decrement or two minus subtracts something just by one. Yeah. So plus equals, and we went over this a little bit last week too. Plus equals is the same thing as saying, hey, we have this value and we want it to be. Oh, how do I explain this? You have a value and you want it to add some value on top of that, but you don't want it to forget. Oh my God.
It's incrementing by a number, whereas plus plus is always incrementing by one. Plus equals can be increment by any number. You just like plus equals and then another number.
Adding something and then setting it to its new value.
Yes. So yeah.
I remember by just saying that I've been like addition. Just that, instead of saying like plus plus is plus one, but if you want to say like 4 plus 5, you go 4 plus equals 5 instead of like 9 equals 4 plus 5.
I'll show it. I will right after this example. I will show it because if I do it in code, I get 200% better at explaining it. Okay, so that's measurable metric. So okay, I just set up these two little things real quick. Boolean is like teaching, string today is equal to Friday. So and so what I'm doing here is, actually, you know what I should do? Just make this a little more readable. Not tour, but true, close. Okay, so within this if, now we're evaluating two different things. And we can, you can have as many of these within your if as possible. You don't want to probably have too many because then things get a little bit complicated. But what I'm doing is I'm going, okay, I'm checking really quick, is Zach teaching equal to true and is today also equal to Friday? So as you might guess, that's going to pop out. FTP, woo, yay, okay, cool. So yeah, so this is just a way of doing multiple evaluations within one if statement or anything. Like you can do this within a while as well. Anytime you have you're checking for something. Additionally, there is something called, so the double ampersand, is that an ampersand? Is that an ampersand? Is that what that's called? Okay, all right, cool.
The and sign? Yeah.
Yeah, okay, ampersand's cool, great. So additionally, we also have this thing, whatever you want to refer these to. I've heard them called pipes before. So this double pipe or like straight line or whatever. So this is going to, as where the other one was and, this is going to be or. So it's going to look and see if at least one of these is correct. So for instance, let's say let's do Tuesday. Yeah. So obviously today is not Tuesday, but if we're looking at today, Friday, pop in here, it's still going to evaluate that and say that this statement here is, technically true, because it's looking, it's not saying, well, how do I say this? And is a little bit more difficult to please because it's looking to make sure that all the conditions that you like sort of set out are true. So if you set 3 or 4 in there and they're all like separated with ands, every single one of them has to evaluate to like a correct statement, as opposed to the or, if either one of these are fine, then it's going to go ahead and fire. So if a good way to show this, fine, whatever. If I put the and in here, we're not getting anything because both of those would have to logically be true, if that makes sense. Yes?
Why is it not crashing?
Why is it not crashing?
Yeah. Like, since you don't have anything that says since it isn't true, how is it just...
It's a conditional statement.
Yeah.
So it's not a loop. So it's not looping infinitely. It's only checking once.
Yeah, so it just checks this. It checks these to see if something in here is like correct, or however it's checking to see is Zach teaching equal to true, is today and is today equal to Friday. And if either of those aren't true, it just skips this. That's all. Oh, sorry. Why do you think it should be?
Oh, I see.
Oh, okay. All good?
Probably.
Okay, that's the hope. Okay, cool. So you'll get introduced to some of those again in intro, or you've seen them already before at some point. Oh wow, that is a lot of operators. Dang.
Yeah, there are more. There are some like pointer operators too that I'm not writing down.
Don't worry about
Some
that
really
unless you're
weird
taking C++.
ones.
Don't. Or unless you're feeling
Well.
unless you're feeling bold.
Yeah.
We should have a pointer day.
Size of is apparently an operator.
Really?
Yeah.
Oh, weird.
Yeah, isn't that weird?
Yeah.
I'm gonna write it down.
Last one that I think is pretty important. It's just the opposite of the double equals. So when we do the exclamation point equals, it's saying, okay, is Zach teaching not equal to true? That's all that means. So exclamation point equals is the not thing. So
Yeah, every time you see exclamation point, that's what it means not.
yeah. So if we go ahead and run this, it's not going to give us anything because this is actually equal to true. In similar fashion, if we change this to false, there we go.
Yay.
And another quick little thing too, since C# knows that booleans are either going to be true or false, you can also just do that.
Yep.
Throw an exclamation point in front of a boolean. That's going to be like, oh hey, is whatever this boolean is false?
Yeah.
Spits out nothing. And similarly, you can just throw in the boolean to be evaluated. Just a little shortcut. You can use the equals equals too. I don't think it's faster or slower or anything. It's just a nice little feature of C#. Last thing I wanted to get to. Yes, the plus equals. Okay, we'll do that really quick. Whew. Throat's giving out.
Zach, I just want to say you gave me so much input for that.
What?
I'm being kind and not saying anything.
I don't want to think about it.
We're inclusive.
That's
I'm joking. Yeah, if any of you have any questions about like any of these operators, also feel free. Like if you're confused about what anything is that I've
No,
written
that's not
down
good.
here,
No, that's not a good example. I can't think of an example for this.
free to ask about them, and we'll talk about them. I only wrote down the ones that I understand. Actually, no, that's not true. There are a lot of other ones, but they're kind of weird. Yay! Because I had a list of C and C++ operators. So C++ you have some like memory allocation operators too. Yay! Like pointers. Yay! Tell me something that likes a pointer. Are the quotes technically operators as well?
Oh, I don't know. They might be.
I didn't see them on the list, so I'm gonna say no. But they do. They are a good like heads up for you. Like, hey, what we're talking about is a string. Hey, what we're talking about is
Good.
Yeah. It's a list of characters. Or it's an array of characters. Yeah. So now we're using all these things. We briefly talked about collections, and now there we go.
Okay. So let's say that we have some integer, some float, some anything that you want to be increased by a set amount. So we have an inventory items that's set to 20 here for a game or something. So what we're doing here is we're saying, okay, inventory items is going to be equal to inventory items plus 65 because we don't want to forget that previous value. So we want to eventually get enough. We want to get 85 of them. What the plus equals is going to do is exactly literally this same thing. It kind of saves you some typing space. So items plus equals 65 is going to do the same thing. It's going to take the value that inventory items is and just accumulate that on top of whatever the previous value is already. So again, let me just show that these spit out the same thing. Get 85 here. So we take that out. We also get 85. So it's just a shorter way of saying, hey, this thing is equal to itself plus another thing, or minus another thing. Minus equals is also, a thing, as you would imagine. Right, yeah, like itself, something is equal to itself plus or minus another value, pretty much. I don't know if division equals. Okay, that's a thing too. Yeah, you can do it with division as well. So something is equal to itself divided by something. It's a little bit more complicated, but. It wouldn't give you an error. It would actually round it. So we can. It might give us either 0 or 1.
I don't know.
Just gives us 0.
C# round or does it truncate? No, C# rounds.
Yeah.
C++ will just truncate it. Just be like, nope, that doesn't exist.
Yeah, since integers are whole numbers, C# is going to want to throw out a whole number. So if you divide it by something that would normally throw it into like a decimal number or something like that, it's just going to give you whatever the closest int is. Yeah. Okay. Make sure. I think I'm still recording. Should be. Hey, look at that. Nice. And the microphone's still working as well. That's nice. Okay. Yeah. We got through both of those. I think I'm gonna cut it off. Folks are seeming a little bit tired. We covered a lot. I don't want to overload everybody.
Does anybody have any questions about stuff we talked about?
Yeah, the stuff we talked about, or even stuff even tangentially related to programming, or.
Like your stuff you're seeing in your homework that confuses you.
Anybody see any?
Not like super relevant. That's fine.
Anyone see any cool cats lately? Literally.
You mentioned vectors earlier, and we're studying that, and I was kind of wondering, are they kind of like lists where you can add things and take things off the top or the bottom, but you can't really mess with them innards very easily?
I think so. If I remember right.
Yeah.
Sorry, it's been like a year.
Yeah, no, honestly, I haven't really looked at. Oh, I wonder if this is. Do you think this is captured? It is captured. I know it. Yep.
Yeah.
All right. Boop, boop, boop.
Yeah.
Dynamically allocated. Oh, use dynamically. So if it's a dynamically allocated array, does that mean that it's pretty flexible? Array
Yeah.
maybe relocate. Yeah, I think vectors are actually like C++'s lists, aren't they?
I think
Sort
so.
of.
Yeah, they're very similar.
Yeah. So from what we can see, they are something called dynamically allocated, which just means it doesn't need to have a set size when you create one.
Which is what are they called, like vectors?
Me and Nathan thought of it as like some kind of like shotgun thing where you load in anything you want, but it can only go in the one end, and it's like you can take it out or take it in, like but it's only one on top of the other, not like a list where it's just kind of reach in the bag and pull out whatever one you want.
Oh, that's a great way to think about that, actually.
If it's that accurate, because I'm not really because like a shotgun is still a set size, so that's maybe it's like a shotgun grows as you more ammo you put in it.
Can you pull stuff from a list from like the middle of it? I've never done that.
Yeah.
Yeah, you can.
Yes. Yeah, you can with a list you can just remove an element and then resize it. So with lists, what happens when you want to pull something out of a list, it has all of its set values and everything. But if you pluck something out of there, it's still gonna have. Oh, wait a second. No, it It might not resize it automatically. A couple of big things that you want to look at when you are dealing with collections. A lot of it's going to be flexibility, function, and speed. What's very common with some of the collections that I've seen in C++ is that there are these things called popping and pushing, which is another way of saying, hey, you can only take out something, whatever you just recently put in, or pop in something from like the back end. So has anyone heard of like a stack and a queue before? Those are two different like data structures that work in pretty different ways, but they're used pretty frequently in C++. I'm getting into uncharted territory here a little bit, but
Yeah.
do you want to explain like stack and queue stuff a little bit?
Second queue.
What's up?
Vectors and queues?
Or stacks.
I don't know.
Yeah.
Hey Google.
Yeah, we're gonna look this up real quick. Yay, programmer. So I mean, essentially, like,
Vector of
popping and
queues.
pushing, I feel
Jesus.
like. So, usually when you pop something out, okay, yeah, actually that's a really great drawing. That was exactly the drawing I was gonna make. That push and pop one. So when you want to add something into a collection, I'm being very general here because I'm not really sure if it's oh, well, in a stack, yeah, this is how it works. So yeah, in a stack, when you're adding things, you're just like putting things on top of each other. It's like first in, first out is what you're gonna hear a lot.
If you've ever worked in food service, or if you've ever loaded a Pez dispenser, that's how those work.
Yeah.
So the first Pez that you put in is the first Pez that pops out of the thing's mouth,
Yep.
or whatever the Pez object is.
Yep. So yeah, and when you're putting things into it, you're pushing it in. So like, think about it like when you're finally putting all your laundry in your hamper, you're just pushing that guy on the top down. That's how the way I like to think about it.
Oh, that's a good way to put it.
And then popping is, I like to think of like the Pez dispenser. It pops out the top. So it's the first one that pops out the top. Usually you'll be dealing with, well, I use stacks more often than, like, the collections I use are usually stacks. Queues are a little weird.
Queues I like to think of as more so like, they're lines at the deli. It's first in, last. Wait.
Is it?
First out.
Oh, sorry. Yeah, no, we do have it backwards. Stacks are first in. Yes.
Oh, okay, yeah.
Stacks first in, last out. Queues first in, first out. So stacks are the Pez dispenser. Queues are kind of like a line at the deli where the number that you grab, you're like, if you grab a number sooner, you're going to be served quicker. So it goes in.
That seems like it should be the other way around.
Do you think?
Those words.
Yeah.
No, I mean like how they're named. Like it feels like it should be the other way around, but it's not.
Yeah.
That's annoying. I'm sorry.
Yeah. Sorry, we didn't really get too much more specific with the vectors, just because we're,
Yeah, we're a little fuzzy.
not too. Yeah, we're
It's been a
very
year.
fuzzy with them. And it
It's-
feels
yeah,
like it's been even more than me.
And vectors are a little.
Yeah,
They're a little odd.
a little bit.
Well, yeah, there's a lot of things in C++ that are like added to it because it's based off of C, which is not an object-oriented language. C++ is just object-oriented C, and so there's kind of like a lot of stuff that's Frankensteined into there, and I feel like vectors is one of those things.
Yeah.
That have been Frankensteined in, and like they make sense, but they're also just kind of weird. Sorry.
Is our answer, yeah.
Sorry.
Anything else?
Anybody else have anything? Did we lose anyone? Everybody feeling good? We're doing a brain.
Yeah, honestly, if there are ever any places where it's like, hold on, wait, that makes absolutely no, like, please stop us.
Yeah.
Like, I mean, our goal here is just to, if we're not being clear, we're not doing our job, and there's no reason for you to come in. So the more clear that we can be for each of you, the better off that we are and that you are. So
Yeah,
yeah.
however you want to get our attention, whether that's like hand raising or just like slamming your hands on your desk. In frustration, I'll accept that.
Anger, confetti, throwing a hand up, it's
Yeah,
all the same.
especially when we get excited, we tend to like just keep going.
Right.
And then, yeah. So if you're just like, boom, that'll just stop us. It'll be good. It'll be good.
Yeah.
Stacks and queues.
Um, what's
oh,
up?
yeah, never mind.
Next week, we're gonna do a crash course, I believe, on functions and classes, and
Yeah.
that'll actually be almost it for like the intro level stuff. Pretty close. I mean, there are a few other kind of going to some access modifier stuff, but yeah. So functions and classes are, two of the big ones that sort of use all of the things that you've learned previously. It combines like the data types and all of the loops and all of the conditional stuff and makes those into usable, manageable, compartmentalized chunks that make your program just easier to use and easier for you to comprehend. So yeah, that'll be big next week for sure.
Yeah, and then I think after that we'll make sure with you. I think we'll talk about things in a more conceptual way instead of, because these first few weeks we've been talking a lot about like syntax stuff, like syntactically what's going on in programming.
Yeah.
But I think it's really important. Like essentially what we've been doing is like, here are tools you have. Like these are things that you can use.
But by the way,
we're talking a little bit. Sorry.
No, go ahead.
And we're talking a little bit about why you would use one over the other, blah blah blah. But I think for the next couple of meetings, we'll talk about more like why is all this happening? Why is this like this? What are we doing? And a little bit, it'll be a little bit more abstract for y'all, but.
Which is also kind of good because then it like opens things up to discussion technically when we're not just like throwing syntax at you. And by the way, if not all of it makes sense, that's totally fine. Again, let me reiterate that. Doesn't make sense now. It will when you start like using it for a little bit.
Practice. All this stuff is going to come up for you.
Right.
We haven't gone over anything where you're not going to use it, except for maybe our brief discussion of vectors.
Yeah.
Sorry.
Okay.
And maybe no, actually, you'll see like all these operators too. Actually.
Yep.
Yeah.
Okay, I'm gonna stop the thing and
Stop it.
call it for the meeting.